All right, we will get started. First of all, thank you all for stopping by for this session. My name is Kunal Jain, and I'm a big data solutions architect at Informatica. And today I will be discussing the topic how to deal with change data in Hadoop. Okay. So with that, let's get started. So this is the agenda for this session. So first of all, we'll go over some of quickly the challenges, what we are seeing in traditional data warehousing. Then also some of the requirements, what are needed for today's data warehouse optimization, right? And I also will be going over quickly on the how does the data warehouse optimization process flow look like? What is the best optimized way? And also, then we will be actually going to the meat of the presentation, which is actually how do you deal with the change data on Hadoop? And then quickly, I have later on a demo after that to talk about that. Okay, so with today's as the data volume is growing and our business complexity is increasing day by day, it is getting harder and it's getting really costly to have so much data available on a data warehousing, right? And thus, most organizations are looking for ways how they can offload some of the data onto some offline places, for example, storage grid or tape backup. Right? Now, obviously, if you offload that data from a data warehouse, and if business users want it, obviously you don't have it. They don't have access to, so they can't make any benefit out of it, right? So those are some of the. So that's one of the challenge, right? The other challenge is, from our traditional grid, the networking is actually becoming a bottleneck, meaning so let's say as the data grows and you want to process more data. Obviously, we need more CPU cycles. We need, so it's getting harder to process the data in a timely fashion, right? So obviously, we are really, getting close on crunching. Basically, our not able to meet our SLAs. So people are having those kind of challenges, right? Then obviously, the traditional data warehouses are not able to handle all sort of, data types, the multi-structured or the unstructured data, all of it, right? So those are the challenges. And obviously, last but not the least, what I have it on the board is the changes. So if you need to make any change to your schema, it takes some time. It takes quite a bit of time because, and then obviously it delays your project deadlines. So what are the requirements from this, right? From today's data warehousing needs. So obviously, what we need is we need a cost-effective scale-out infrastructure to support your unlimited data volumes, right? Also should be able to run your, basically have your infrastructure on commodity hardware, and obviously rely on some of the softwares and the open source software, et cetera, right? But also, you want to be able to leverage the existing skills that you have for your operational cost, to lower your operational cost, right? So those are some of the things, right? So customers are looking for the requirements, and also should now be able to support most of all other new data types that are out there, which traditionally you were not able to do it in your data warehouse, but those are some of the things that we needed now in our data warehouse, right? Should also be able to support the new agile methodologies for schema on read. So you take everything, dump everything here in your Hadoop, let's say, environment, and then read it as you need it, right? And obviously, last but not least, you need to be able to integrate with existing any new types of infrastructure that you're bringing into your environment. So what is the data warehouse optimization process flow look like, right? So obviously, the very first step is you need to identify any unused data or infrequently used data in your data warehouse, right? You need to be able to identify that and offload that to the Hadoop environment that you're trying to set up. Not only that, but also any transactions that are taking a lot of CPU cycles, spending a lot of time on the just on the data warehouse, on the processing itself, you can offload that as well to the Hadoop environment. The next step is obviously you can start taking data directly from your transactional systems, your relational systems or relational databases or mainframes, or even from the documents, social media, cloud, machine data. You can start bringing in that data into the Hadoop environment. Obviously, you can use to do that. You can do several things. You can start creating your chain data captures. You can start doing even real-time feeds into this environment, if need be. So things like those, right? But one important point actually I want to make from here is, so the first step is obviously you get data from the data warehouse, right? So you get all the historical data. But the next step is when you're actually bringing new data, the incremental data, how do you deal with that, right? What are some of the things that you need to look for? And basically, how do you deal with that updates that are happening in your environment? So to that, we will discuss in the upcoming slides. So next, so obviously that now you have data in your Hadoop environment, you need to be able to process the data, right? Apply your any data cleansing, data quality, some of those checks here, and make the data ready to be consumed by the business users, right? So you should be able to parse and process the data in the Hadoop environment. And finally, once the data is ready, you can take the subset, the aggregated data, and back from your Hadoop environment to your data warehouses. And so your business community can start using that data from the whatever platform or the data warehouse they were always using. They can start using that data from. Okay. So with that, I'd like to discuss a use case. Basically, like I said before, right on the previous slide. So the first step is obviously you can take the historical data into bring it into your Hadoop environment. But the incremental data, how do you deal with it, right? So going back to obviously traditional data warehouses, it's very straightforward, right? You can do inserts and updates, and it's no problem. But here, so let's take an example here, right? So let's say you have a historical table, which is 10 billion row table, right? So you load it one time into your Hadoop environment, great. Now next time, obviously you're bringing new data, let's say incremental data, which is 10 million rows. And from the incremental data, this is, let's say 70% are new, 70% are inserts, and 30% are your updates, right? So insert is fine, updates, we need to look at it. But in traditional database, like I said, right, obviously you can do it by using simple inserts and update statement. However, the challenge becomes, because now that you're dealing with large data, 10 billion row, a big size data, it's not that cost effective, right? And that's why people are looking for big data solutions. So to big data solutions, obviously, so you can leverage Hive here to store that massive amounts of data. But again, now the problem right now here is that Hive does not support any updates, right? So one way is obviously to update your tables is when you're bringing new data is to do a full table refresh, right? Yes, it is practical for smaller tables. However, it is not really practical for the big tables, right? Like, for example, that we are talking about 10 billion row table, right? So obviously, to do that, if you had to update that big table every day or nightly or every few hours, which is not practical, it is definitely going to blow your SLAs out of the water, right? So to demonstrate that, let's quickly walk through scenario here that, for example, let's say this is the data. This is a historical table. I'm just showing only 3 rows right now for the demonstration purpose. But assume it's a 10 billion row table. So the 3 transactions are these. Now, next day or whatever next time, you bring in the staging table, the incremental data, right? So the red row I'm representing are the updates that are happening, and the green are the new inserts we are bringing in, right? So again, showing like kind of 70-30 percentage just to give a flavor, right? And in the update, what we are actually updating is, if you see from the transaction ID 1, is basically the amount, which was 200, and now it is 210, okay? And obviously with that, so the final table should look like, after this is applied, the incremental data is applied, should look like this, right? So, so your update has already happened for the amount. You have your old data, 2 and 3 rows, the transaction ID, and then you also have 4 and 5 as the new incremental data, right? So that's what we need. Now to achieve this, we can leverage the high partitioning, right? So by partitioning on a specific column, obviously we are restricting only that much data that we need to go after, right? So again, and to demonstrate that actually, well, actually first thing is, yeah, I think just diagrammatically, how will it actually look like, right, overall? So the very first step is, like I'm showing here, is you update your, oops, why is it going forward? Okay, so you extract your target table, right? You have it at the lower bottom. Then your staging table, you bring in new data. You have the inserts and updates there. The next step is, obviously, you want to join those two tables. And first of all, figure out what are the partitions for your target table which are impacted. You have, so we'll put it in a temp table, and then join it with our staging table to figure out which of those are actually getting updates. And then, so we have the temporary table in the middle, which has the impacted rows. And by impacted rows, which is actually the rows which are, so there are, of course, there are updates and insert, but also the impacted row, what I mean is the rows which are not impacted, but we actually did bring it from our historical table, right? So we have that. And then the third step is, obviously, we delete the partition, the impacted partitions from our target table, and lastly, we load all the data back into the target table. Okay. Now to demonstrate that, actually, I do have a tool, but the tool what I'm actually going to talk about is the Informatica Big Data Edition, and this is actually, this tool, obviously allows you to write your data flow, your data pipeline in a GUI fashion. Obviously, you can define all your sources, your business logic in terms of transformations, what you want to do, and the end result, obviously, whichever you want to export it to, basically a file or a table, etc. So you have your targets defined as well. So you define your whole mapping. So like I'm showing here, obviously it's you do not need to know any code how to write your logic on Hadoop environment. So you can create your mapping, you can run it directly on a Hadoop environment, right? So obviously this tool also allows a few of the things that, so basically you can preview data at any point in time. So it's really useful for the developers, when they're building a logic, they need transformations and expressions, how it should be processed. They can look at it exactly, they can select that specific transformation and run your mapping up to that point to see how the data will actually look like, how it's transformed up to that point. Okay. Okay. So with that, actually, I'm going to turn to a demo to showcase this using this live tool. All right. Thank you. So what do we have here is, so what we have here is the Informatica Big Data Edition tool. And through this, this is exactly the tool that I was talking about earlier, right? So you can define all your, your projects, your mappings, and your, workflows here. And then obviously, this is the place where you will do it, define these. So what I'm showing here in my first screen is, so if I have to go back, if you remember, the first step is we need to load the historical data, right, from our whichever relational systems or flat files or whatever, in whatever format, into the Hadoop environment. So assuming I have this mapping, right, so what I'm showing here is it's a local local file system, file is sitting in a flat file format, and I'm writing to a Hive table, right? The next thing is the whole workflow, which I am actually running it, let's say, every time the new data, incremental data comes in, right? And what I'm showing here are a few steps here. So the very first step is I am actually ingesting the incremental data, taking it from the, let's say, local file system and moving it into Hive tables. The next step is, and which is actually, I'm showing it right here in this format, right? So I take it from the local file system and I write it to a Hive table. The next step is actually to basically find any upserts, right? So basically any inserts or updates that are happening from this. And for that, we have this mapping. And by mapping, again, it's just a data flow, a data pipeline that we are calling about here, right? So what am I doing here? So this is the very first step is obviously I need to identify all the partitions that are impacted for my historical table, right? So I'm reading the historical table, basically trying to find all the partitions which are impacted. Sorry, take it back. The first step is actually I'm reading the incremental table to figure out what are the partitions that we are getting in that data, right? And then getting the list, and then I'm joining that partitions, as you can see at the bottom, is the data preview for what data is actually whatever data is being collected up to this so far, right? And I'm joining that data with my historical table. So this is, let's say, the historical table that I have right now, and I'm joining it in here, and I'm doing an equi-join on this. And then finally, what I will have here is all the partitions which are actually getting impacted, right? So these are the two partitions. In this example is 2013 January and 2013 03 March. So I will have this data, join it with this, and what I'll get is actually rows number, transaction ID 1 and 3, right? Because I have the partition ID is 1 and 3 here. So after I join that, finally I come back and join my incremental data, which is the staging table that I said, and I'm joining it, doing a full outer join to determine which of these rows, which I have it in my previous step, are actually inserts new data, right? Again, which I'm getting it from the incremental or the staging table, we're calling it, or the updates, which are again coming from the incremental data, which is these ones. And finally, the last logic is basically the old records. So like I said, so because we are bringing all the data for those partitions from the historical table, we will have some rows which are updates, but we will still have some rows left over which are not actually updates, but we still need to carry forward because the next step is actually we are going to, so before I go that, so obviously we bring in those old records and we join it together and we put it in a temporary table, right? The next step in my workflow is basically I come back and I drop the partitions which are in my historical table. Again, looking at from the historical list, the get partitions, we drop those partitions, and finally, what we want to do is we actually want to load the temporary table back into the target table. Okay. So so obviously we can do this, and so that was the tool, the Informatica developer. It was a Eclipse-based tool. It's a Eclipse-based tool. Like I said, you can define all your mappings, your workflows, everything here. And we also have the administration tool here, through which you can run so you can deploy your mappings or applications, and you can run it from the administration tool. Let's say, for example, here. So you do run mapping, the run workflow, what we created, and it'll run in the background. At the same time, it will also display the progress, how it is actually progressing throughout this. So we can go to whatever step, right? So so obviously this is actually running, and this will finish whenever it'll finish, but. So that's all actually I wanted to show from the demo, but if we can switch back to the presentation. Okay. So yeah, we already covered this with the demo, because originally I was thinking of going through slide, but I thought maybe it's better if we can do it in demo, see a live tool out there. Now, so one of the first things that Hadoop developers face is challenges that how do you get data from so many different data sources out there into the Hadoop environment, right? So obviously you can build a custom adapter, but again, it needs a lot of effort because there are a lot of things that goes with it, right? So obviously you need to have the skills, the knowledge about any new data source that you're bringing data from, right? What are the data structures? How is it? What is the best way to bring data in, right? The second thing is obviously not only the knowledge, but also you need to be able to have your adapter ready to scale at the amount of you're bringing data in from, right? So as your data volume grows, you need to make sure that those adapters are can perform as per your needs. Then obviously along with that, it comes the security part, right? So you need to make sure, because you're bringing so much data, you need to have your adapters have the security part as well. So obviously, it is possible to write your own custom adapters. However, on the other hand, like I said, it's a challenge, right? On the other hand, Informatica actually provides a lot of adapters to virtually any data source, and you can bring data in using these adapters from any data source into your Hadoop environment, right? And also, what it offers it actually, obviously, like I'm showing here, is you can load, you can replicate from the data sources. You can archive. We have tools out there to do that. And so that's the first part, bringing in data, right? The second is also you can do a lot of other things like profiling, parsing your data set, your ETL, running your basically transformations in batch mode, right? So you write your own mapping, you write the mapping logic, and you push it down onto Hadoop, how to process that data, right? And it will run directly on Hadoop. So that means you're not bringing data out from there. So obviously you can do cleansing and some address matching, et cetera, with our tool as well. And finally, the third step is obviously you would, once your data is there, yes, you can consume it directly on the Hadoop environment, but also you can take that data out, again, using the adapters that we offer in our product in different ways. You can do that, move it to a data warehouse, et cetera. So just to summarize, so Informatica on Hadoop, what are some of the benefits? That obviously, that it's cost effectively, scale storage, processing. So we're seeing over 2x of the performance. The other thing is that the increasing your developer productivity, right? So this is really important because whatever skill set you have today, let's say for the ETL processing, you can leverage those resources to run your transformations logic on Hadoop. They don't need to learn new languages or write own code, right? So you can leverage. So what we have seen for some of our customers was they were able to get actually 5x productivity by just moving from hand coding using Informatica tool. And the third, the other thing is obviously that what we just discussed, we showcased using this Informatica tool, right? You can easily write your logic for upserts, right? We just demoed right now. So you have the capability of doing that. And most important is, we ensure that, so you're actually, and we ensure the success with a proven leader in the big leader in the big data and the data warehousing space. So that's all I have. Again, thank you all for coming, and if you have any questions, I'll be happy to take. Do you mind actually, sorry, please stepping up. Okay, the mic. Thank you.
Hey, on that absurd demo which you said, the problem there is we had to do a union all on those large tables with billions of records, and that could take a very long time,
So,
right?
yep, good question. So the union all was actually on a subset of the data. It was only union. The equi-join. We were doing it. So actually, I do have it on the slide, so I can actually walk you through that as well. Right here. Oh. So the very first step, if you see here on at the bottom, the first join is actually the equi-join. And what we are doing is we were actually getting just the partitions, what we need to get from the historical table, right? And once we have those partitions, only those partitions, the data, we actually are getting it from using the equi-join, the full outer join from the historical table, only for those partitions. Yeah? And then obviously we were applying our logic to inserts or updates based on that. Okay. Any other question? Okay, then we can wrap up. Thank you all again for stopping by for the session.